joint working team formed by
Saludos González, Oscar Negrete,
David de la Vega.
and Emilio Pereira. And today we will present a brief overview of our network implementation project for UPAEP.
UPAEP requested a complete network infrastructure for 4 buildings: Vinculación, Edificio T, Edificio A, and Book. Each building contains 4 floors, and every floor has different types of users. For example, students, administrative personnel, academic personnel, as well as printers and IoT devices like lamps and coffee machines. All these networks needed to use public IP addresses, so we created a full BLSM plan for each building.
This is an example of one of architect's files. As you can see, each floor is color coded so the topology is clear and easy to maintain. Every floor contains its own router and fuse and switches, and all floor routers communicate through serial connections. Thanks to this structure, any networks or any floor can reach all the others inside the same building with a static routing.
During subnetting, we had an inconvenience with Edificio A. Its assigned public network was a clase which did not have enough IP spaces to handle all the floor devices. To solve this while keeping the BLSM strictly ordered, we incorporated an additional class B range into the same BLSM chart. This allowed us to maintain the consistency and avoid redesigning the structure.
Before explaining the advantages and disadvantages, we want to show how each building is interconnected internally. Each floor contains 3 routers dedicated to managing the internal networks of that floor, but there is also a 4 router per floor, which is responsible for connecting that floor to the other floors of the same building.
All floors are linked using a hierarchical structure. At the top, there is a new build router designed for future expansion in case UPAEP wants to connect the building to another building or external network. This new router connects directly to the router at floor 1, which serves as the core of the building. The floor 1 router connects to the other routers in the same floor, and it also connects upward to floor 2 and floor 3.
Then, the floor 3 router connects to the floor 4, completing the vertical structure. This creates a clean and organized routing hierarchy, where each router knows exactly when to set traffic. Inside each floor, the router distributes connectivity to switches and the 8 devices. Although in the packet reset, we only show 2 switches per floor. This is a simplified model. In a real implementation, there will be more switches, but the logical design will be remain identical.
All router-to-router connections are made using serial cables, ensuring clear point-to-point links. Switch-to-switch connections use copper crossover cables, and end devices like PCs, printers, servers connect to switches using copper straight-through cables. This keeps the network consistent with industry cabling standards and ensures proper communication at every layer.
One of the biggest advantages of our design is redundancy inside each floor. We install 3 routers per floor, so if one router fails or gets disconnected, the other routers continue providing service normally. This increases reliability and ensures that most devices remain online even during equipment failure.
Another advantage is clarity and scalability, because each building follows the same structure model. Future expansion becomes easier. UPAEP only needs to replicate this pattern to add more networks or devices.
Another important advantage in a long-term cost efficiency, although the initial deployment may appear inexpensive, the design actually reduces cost in the long run, because each floor uses a single router to implement its networks. The number of devices is still manageable if this lower maintenance expenses, avoiding necessary purchases, and allow time to recover the investment easily over time. One limitation of our designs in that building has one main router path, meaning the routers are not interconnected in a mesh. This means there is multi-path redundancy connecting all the routers together. If the main building routers fails, communication between floors would be affected.
However, this limitation was intentional. The project requirements focused on serial connections and clear hierarchy, so a more complex multi-router architecture was not appropriate for this scenario. Our design respects the requested topology while keeping implementation and maintenance straightforward.
Our proposal offers a strong balance between stability, clarity, and efficiency. The network is easy to understand, easy to maintain, scalable for future growth, and reliable even during partial router failures.
We also maximized the use of public IP addresses through an optimized BLSM plan, saving resources while keeping the network structured and professional.
Our team ensured that the building has full connectivity, clear segmentation, and strong organization across all the 4 floors. The design is not only functional but also visual, clear, and well documented.
For these reasons, we believe our solution is the most balanced, efficient, and professional option for UPAEP. We offer technical quality, redundancy, and simple administration that will be useful for many years, resulting in future cost savings.
Thank you for watching. We look forward to working with you and supporting UPAEP with a reliable and scalable network solution.